This video is on electricity, one of the most important and long and difficult topic. Not difficult, but confusing topic for GCSE. So let's get started. The first topic is electric current. Electric current is sometimes is asked what's the definition, state the meaning, or define electric current. So this is nothing but rate of flow of electric charge. So be careful, if you don't write the word rate, that means you are not getting the full marks. Rate means that you're dividing charge by time to get current. Say current, which is denoted by I, this is defined as charge divided by time. So whenever you have something divided by time, we call it as a rate. So rate of flow of electric charge is current. Now, if you rearrange this equation, charge is denoted by Q and this is time. So if you rearrange this equation, you get charge as current times time. And also you need to remember the units. The charge is always measured, or standard unit for the charge is coulombs, and the standard unit for current is amps. But most of the time the current would be given in milliamps, so you need to convert milliamps to amps by dividing by 1000. So 1 milliamp is 1/1000 amperes. Simple question, always underline what is given or circle what is given. So I'm circling 60 coulombs, 12 seconds. It's asking current. Current is rate of flow of charge. That means charge divided by time, and that gives you 60/12. That is 5 amps. Simple. Only if we know it. Okay, it is not very difficult. Only thing is that we need to understand what is what. So if you remember that charge is coulombs, current is amps, and whenever you're measuring current, that is nothing but the rate of flow of charge. Now, Ohm's law, another favorite topic of the examiners. So what does it says is that potential difference through some kinds of conductor, which are known as ohmic conductors, is directly proportional to the current. That is, if the potential difference is increased, the current in the conductor also increases, but it increases with a constant gradient. So if I draw the graph for potential difference in current, it would be a straight line. So this is potential difference measured in volts, current measured in amps. So this line, because it's passing through origin and is a straight line, is a directly proportional graph. And what Ohm's law says as potential difference is directly proportional to the current, and the gradient of this graph gives resistance. So a larger gradient would mean larger resistance. For example, if I have a graph in which there is two lines A and B, which of them would have higher resistance? B has higher resistance because B has higher gradient. Gradient means slope. B has higher slope, so B has higher resistance. Now, what is resistance? Resistance is the obstruction to the flow of charge. When the charge tries to flow through the conductor tries to stop it. That resistance, that obstruction is called resistance. It is measured in ohms. And if you want to see the equation, which is there in your equation sheet, resistance is potential difference divided by current. I'm speaking the word, but I'm writing the symbols because knowing the symbol helps you to understand what they're asking. Now, current. Current, we have already seen, it is a rate of flow of charge. Quickly ask yourself, what is current measured in? Current is measured in, yes, it is amps. Now, Ohm's law when it applies to whatever kind of conductors, they are called ohmic conductors. So the component, the electrical component that gives straight line between potential difference and current are ohmic conductors. Like we have, you must have done this experiment. If not, you must have seen the graph for the filament lamps, which I'll do in the next slide. So if the graph is not a straight line, if the graph is a curve like this, that's a filament lamp curve. So this means it's not an ohmic conductor. Ohmic conductor, the graph would be a straight line. Now, what are the different kind of circuits? You have different types, series and parallel circuits. In series circuit, so I'm going to just make a simple series circuit here. So a cell, and I have two lamps. Okay, say two lamps, and then I don't know why it is not making the bigger line. Oops. Say, all right, so there is some problem here. It just doesn't want to make the bigger line for the battery. Okay, let's just make, anyways. So if I have a series circuit, let's just try and make a circuit here. So if there's a series circuit and I have two lamps in a series circuit, the current is same at every point. So a current starts from here, whatever current goes into the first lamp, same goes into the second lamp, and the current is same everywhere in a series circuit. Potential difference would divide. If this battery is, let's say, 1.6 volt battery, so each of the lamp would get half of it, 0.8, because I'm assuming that both the lamps are identical, so 0.8 to each. So the voltage is shared. And then resistance, the total resistance would increase if you have two lamps or three lamps or four lamps. The resistance in series always increases. And sometimes they will ask to find the total resistance, so just add them. So the total resistance would be resistance of the first plus the resistance of the second. For example, if this lamp has 1 ohms and this lamp also is 1 ohms, the total resistance would then be 2 ohms. Remember, this is a quick revision video. If you want in detail, then there would be a different video. So if one lamp fails, now the current is flowing in series through both of them. If one lamp fails, the other is not going to get any current, so none of them works. Okay, so none of them then works. Whereas in parallel, it would be a different case. We'll see parallel in a minute. Example is Christmas lights. Old Christmas lights used to be like that. So if one of the bulbs would fail, the other bulbs would not work till you find out which bulb has fused, which was a task you can't easily find out. Remember, Christmas light has so many lights in it. So if one of the lights fails, one of the bulb fails, it is difficult to find out which one has failed. But the entire Christmas light would just go wasted because none of them would work. All of them are in series. Now a simple parallel circuit. Let's a simple lamp again. I'm again using a same circuit. So I have two lamps, but this time my lamps are in parallel. Okay, so this one is the lamp in parallel. So what happens is now the current starts from here. Now if you draw this circuit, you're not getting marks in your exam. It has to be a straight circuit without any break in the circuit. So just going to erase it. So what happens to the current is the current always divides in a parallel circuit. So if I take a 5 amp current starting from the battery, it's going to divide into the two lamps. If the two lamps are not identical, one will get different current, the other will get different current. So I'm assuming this one has low resistance, let's say 2 ohms, and this one has high resistance, let's say, oh sorry, this one has low resistance and this one has high resistance. Low current means high resistance. So what happens to the current? Current is shared, but the potential difference, it remains same. So if the battery potential difference is 1.5, both of them will get 1.5 volts. This is what happens in our home. Our homes receive 230 volts from the supply, and every appliance will get 230 volts because the potential difference is same. In our homes, our circuits are in parallel to each other, so whatever potential difference is applied is same across every appliance. Your TV, your boiler, or your fan, or your air conditioning, everything receives 230 volts, but they get current according to the resistance. If they have high resistance, the current would be low. If they have low resistance, the current would be high. So now why do we have things in parallel? So that if one thing goes off, let's say you have one bulb in your house which fuses, the other would still get the current. So that's the thing. So if one of the fails, the other keep working. Okay, so the others work. Now, example is your house circuits or house wiring. Okay, they are all in parallel. Resistance. Now the total resistance in parallel always decreases. So if I buy a fan and add another fan in my house, the total resistance of my house circuit would decrease and it would draw in more current from the supply. I need more current because I want to switch on another electrical device. So total resistance in parallel decreases, in series increases. Now, if energy is being used in the circuit, there would be some power use. So power is, the most common formula is power equals energy divided by time. Energy is measured in joules and time is measured in seconds. Power is measured in joules per second, but it is also known as watts. So if I have a 10-watt bulb or a 20-watt bulb, that just means the 10 watt is using 10 joules per second, 20 watt is using 20 joules per second. So the other formula, which is sometimes used, again, you have these formulas in your equation sheet. Say power is, if the potential difference is unknown, we use this formula. I squared times resistance. So I is the current. So you square the current and you times it by resistance. If I is unknown, then you calculate potential difference, or it's given in the question, square it and then divide it by resistance. In all the cases, the unit of power is watts. Sometimes energy is measured in kilowatt hours, and we need to convert kilowatt hours into joules by first multiplying it by 1000. Remember, kilo is 1000. Then multiplying it by, how do you convert hours into seconds? By multiplying it with 3600. That's it. That's how you convert kilowatt hour into joules. Now, a simple question. A 230 volt, remember, always circle your data 8.5 amps. So I have potential difference as 230, current is 8.5, power output. So power output, the equation which I'm also using, this another equation which you will find in your equation sheet, is potential difference time current. So this is the equation I'm using now. So I'm using 230 times 8.5, which is 230 times 8, so that is 1955 watts. And then you have the power now. Now it's asking you how much energy would it use in 3 minutes. So watts means joules every second. So it is using 1955 joules every second. So how much joules would it use in 3 minutes? So what you need to do is then times 1955 by 3 first, and then times it by 60, which is, so times by 3 and then times by 60. So I'm getting answer as 3,5. No, that is not the right one. So answer is 35900 joules. Now IV characteristics. IV characteristics means we need the graph between current and potential difference. If it is an ohmic conductor, we already know the graph would be a straight line. Okay, please use ruler and a pencil when you're writing in your exam. So a straight line between current and potential difference. Whereas if it is a filament lamp, it's not an ohmic conductor. Why? Because resistance does not remain constant. And because why resistance changes? Because as it gets hotter, resistance increases. And if the question asks you what is why the resistance changes, is because as it becomes hotter, the atoms of the conductor vibrate more. Charge electron that is moving through the conductor collides, making it difficult for the charge to travel through. That increases the resistance. So for that one, go through the video which has filament lamp in it. Okay, next one is diode. So if I am drawing the graph for the diode is a non-ohmic conductor. It allows current only when potential difference is positive. Okay, but if it is negative, so as you can see, there's no current in this direction. Okay, I can just erase this. So there's no current when the potential difference is negative. So that is why the diode is used in the circuit where we want to allow the current only in one direction. So it allows only when the potential difference is positive. Thermistor, again a non-ohmic conductor. Resistance changes when the temperature changes, so it decreases when temperature increases. So if it is hot, temperature is less. When it is cold, temperature resistance is high. So we have resistance here. Now main electricity and safety. So direct current is the current that does not change its direction. Okay, this is most important, does not change its direction. So this was a question I was seeing the other day with my students. What are the two types of electricity? So DC and AC. DC is direct current. I'll just draw a diagram here which will help you to remember. See, the direct current is a constant graph. So this is current and this is time. So it's not changing with time. Whereas if I say alternating current is a current that continuously changes its direction. So see, going up, down. So that's your alternating current. Just to help you remember. Changes its direction continuously. Direct current does not change its direction. The 3-pin plug. The brown is the live wire. What's the use of the live wire? It carries the 230 volt AC supply to the appliance. Blue is a neutral, takes the current back, so it completes the circuit. Safety wire is the earth wire. Okay, this is connected to the metal casing. In case sometimes the current goes to the casing, let's say for example somebody in your home is cooking food in an oven. The body of the oven is metal. There is a fault in the circuit. The current goes in the body of the oven. So if somebody touches it, the current would get a low resistance path and would flow through the body of the human, giving them an electric shock. So then if there is an earth wire in the oven, whatever extra current is there in the body of the oven, because of the earth wire, the current would go into the earth. So that is, so this symbol here is the earth. So all of the extra, so it just prevents, that's a safety. Earth wire acts like a safety. We have fuses. Again, we also have fuses in case the current, if the current starts flowing through the human, it would be very high because human would have low resistance. So the fuse would melt in case the current becomes too high. So that is, if the fuse melts, the circuit breaks, current stops flowing. These are the equations. You have these equations in the equation sheet. You should be able to rearrange them. If not, just give me a message. I'll try and make a video which would tell you to rearrange. I've done the first one. So if I want to find time, the I go under charge. Similarly, if I want to find potential difference V, where would the I go here? Go ahead, try. Yep, it will go under P. If I want to find R here, or if I want to find I, where would the R go? R would go under V. So you should be able to rearrange the equations, check the units. Time should always be in seconds, but in the questions it will be either in minutes or in hours, so convert them in second. Some simple questions, go ahead, pause, and then check the answer. Once you've done it, go and check your answers, and that's it for today. So this is electricity in a quick fire way, and well done for revising. Thank you for watching, and subscribe. Thank you so much.